So in today's video, we are going to study trigonometry. We'll be talking about the Pythagoras theorem, basic trig ratios, and all of that. So what is trigonometry? Trigonometry is basically the branch of mathematics that studies relationships between side lengths and angles of a triangle. Now in this video, we are going to focus more on right-angled triangles. A right-angled triangle is a triangle which has one of its sides being 90 degrees. So let's consider a right-angled triangle. We have this right-angled triangle. One of its angles is 90 degrees. That makes it a right-angled triangle. Now let's label the sides of this triangle. So this is side A, we have side B, this is side C, and this is the angle theta. Now the longest side of this triangle is called the hypotenuse. The longest side is the hypotenuse. And then the opposite side to the angle theta is called the opposite. So this is the opposite. And then the other side is called the adjacent side. So this is the adjacent to the angle. Now assuming I'm going to create an angle alpha here, then opposite to this angle alpha is going to be the side B, and then adjacent to this angle is going to be side A. So basically the opposite and then the adjacent sides of a right angle triangle can change depending on the angle of reference. If you are going to reference the angle alpha, then the opposite side to this angle is going to be side B, and the adjacent side is going to be side A. Whereas if you are going to reference the angle theta, then opposite of this angle is side A, and then adjacent to this angle is going to be side B. Now in this video, we are going to focus on the angle theta. Now from Pythagoras theorem, the square of the longest side, the square of the hypotenuse, is equal to the sum of the squares of the other two sides. So c squared is equal to a squared plus b squared. And then c is equal to the square root of a squared plus b squared. Now let's talk about the trigonometric ratios. I believe that you've heard of SOHCAHTOA. So the S stands for the sine function. We have C, that is the cosine function, and then T is the tangent function. Now from this triangle, sine theta is equal to, we have the opposite over the hypotenuse. So opposite over hypotenuse. We have the opposite side to be A. So we have A over the hypotenuse, which is C. So A over C. Now to the cosine function, we have cos theta equals the adjacent over the hypotenuse. So we have adjacent over the hypotenuse. So that is B over C. And then also we have tan theta equals the opposite over the adjacent. So opposite side over the adjacent. And that is A over B. So basically, this is how to find the three basic trig ratios given a right-angled triangle. Now let's move on and take some examples involving how to find the length and angles using trigonometric ratios. So let's take our first example. Example 1. Find the missing side and angle theta in the figure below. Find the missing side and angle theta in the figure below. So here we have a right-angled triangle. We have the opposite side to be 4 and the hypotenuse to be 5. And then we are going to find the missing side, which happens to be the adjacent and the angle theta. Now, since we don't know the adjacent side, we are going to represent that with a variable. So let the missing side be x. Now, from Pythagoras theorem, we say that the square of the longest side, which is the hypotenuse, is equal to the sum of the squares of the other two sides. So that is equal to 4 square plus x square. 5 squared is 25, so we have 25 equals 4 squared is 16 plus x square. Now we transpose 16 to the left hand side. We have 25 minus 16 equals x square. 25 minus 16 is 9. So we have 9 equals x square. And then we say that x square is equal to 9 because it is the same thing. Now we are going to take the square root of both sides. We have the square root of x square equals the square root of 9. The square cancels the square roots. We have x equals 3. So the missing side is equal to 3. Now let's solve for the angle. Let's find the angle theta. So to find the angle theta, we can use any of the trig ratios. We can either use sine, cosine, or the tangent. However, I'm going to use the sine function. So sine theta is equal to, now for sine, is going to be the opposite side over the hypotenuse. Now we have the opposite side to be 4 and the hypotenuse to be 5. So we have sine theta equals, now 4 divided by 5 is the same as 0.8. Now because we want to find theta, then theta is equal to the sine inverse of 0.8. And then we have theta to be equal to 53.13 degrees. So this is the angle theta. Therefore, we have x to be 3, and then we have angle theta to be 53.13 degrees. Now let's move on to the second example. So to the second example, find PQ and PR in the figure below. We are going to find the length PQ and PR in the figure below. Now in the previous example, we had two sides given, and then we are asked to find the missing side and the angle theta. However, in this example, we are given the angle theta and the hypotenuse, and we are asked to find PQ and then PR. So first of all, let's solve for PQ, the length PQ. Now PQ happens to be the adjacent to this angle, the 60 degrees angle. Now if we are going to find the length PQ, which happens to be the adjacent, and we have the hypotenuse, then we can use the cosine function, because cos 60 is equal to the adjacent, which is the length PQ, over the hypotenuse, which is RQ. So we have cos 60 equals PQ over 8, and then because we want to find the length PQ, we multiply 8 by cos 60. Now cos 60 is 1 over 2, so we have 8 times 1 over 2, which is equal to 4. So the length PQ is equal to 4. Now let's find the length PR. So this is PR. Now this is the opposite side to this angle. We have the hypotenuse, so we can use the sine function. So we say that sine 60 is equal to the opposite, that is PR, over the hypotenuse, RQ. So sine 60 is equal to PR over 8, and then PR is equal to 8 sine 60. Now sine 60 is root 3 over 2. So we have 8 times root 3 over 2. And then 2 goes into itself once, into 8 4 times. So that is 4 root 3, which is equal to 6.93. So this is the value of the length PR. Therefore, we have PQ, the length PQ to be 4, and then we have the length PR to be 6.93. Now to example 3. In the diagram below, angle PQS is 50 degrees, angle PRS is 30 degrees, and the length PR is 8 centimeters. Find QS. We are going to find the length QS. We have this angle to be 50 degrees, we have this to be 30 degrees, and then we have PR to be 8 centimeters. We are going to find QS. Now to find the side QS, considering this triangle, the triangle PQS, we have this angle to be 50 degrees. Now we don't know the length PS, neither do we know the length PQ. So we can't find the length QS. Now in solving for QS, we need to find at least one of the sides of this triangle, that is PQS, so that we combine that with the angle PQS, which is 50 degrees, so that we can find the length QS. Now because we don't have something like that, we need to work out this triangle, that is the triangle PSR. So for the triangle PSR, we can try to find the length PS, so that we combine that with this angle to find the length QS. So first of all, let's work out this triangle PSR to find PS. So from triangle PSR, we have this angle to be 30 degrees, and then we have the hypotenuse to be 8 centimeters. Now because we want to find the opposite side, which is PS, we are going to use the sine function. So we say that sine 30 is equal to the opposite side, which is the length PS, divided by the hypotenuse PR. So we have sine 30 equals PS over 8 centimeters over 8. So that we have PS equals 8 sine 30. So PS equals 8 sine 30. Now we have sine 30 to be 1 over 2. So 8 times 1 over 2, that is equal to 4. So we have 4 centimeters for the length PS. Now since we've gotten the side PS, we can combine that with this angle to find the side QS. So from triangle PQS, this triangle, we have the opposite side, which is PS, and then we have this angle. Now we are looking for QS, which happens to be the adjacent. So we are going to use the tangent function. So tan 50 is equal to the opposite, which is PS, over the adjacent QS. We have PS to be 4 centimeters divided by QS. Now we can interchange the positions of tan 50 and then QS, so that we have QS to be equal to 4 tan 50. Tan 50 is 1.1918. So 4 divided by 1.1918 gives us 3.3563. And then to 2 decimal places, we have 3.36 centimeters. So this is the length QS, 3.36 centimeters. So for example 4, in the diagram below, the angle SPR is 60 degrees, angle SRP is 90 degrees, side PS is 20 centimeters, side PQ is 6 centimeters, and then side QR is X centimeters. We are going to find I, X, and then II, SR. So this is X, QR, and then this is SR. So first of all, let's find X. Now in here we have 3 triangles. We have SPQ, SPR, and then SQR. Now to find X, we are going to consider the triangle SPR, that is the bigger triangle. We have the hypotenuse side to be 20 centimeters, and then we have the side PR to be 6 plus X centimeters. Now PQ is 6 centimeters, and then we have QR to be X centimeters. Now to find X, we are going to find the full angle, that is PR. Afterwards, we are going to subtract PQ, which is 6 centimeters, from the full length PR, so that we can get X. So that is exactly what we are going to do. So from triangle SPR, we have the hypotenuse and the adjacent. So we are going to use the cosine function. So we have cos 60 to be equal to PR, that is the full length, divided by PS. So that becomes cos 60 equals, now PR is 6 plus X. So we have 6 plus X divided by PS, which is 20. So at this point, we can cross multiply. So we are going to have 20 times cos 60 equals 6 plus X. Now at this point, the full length PR is 20 cos 60. Okay, that is the 20 cos 60. And then because we are interested in X, we are going to subtract 6 from 20 cos 60 to get the value of X. Now cos 60 is 1 over 2. So this becomes 20 times 1 over 2 equals 6 plus X. And this gives us 10. And then we transpose 6 to the left hand side. We have minus 6 equals X. So that we have X to be 4 centimeters. So this is the side X, QR. Now let's find the length of the side SR. Still focusing on this triangle, that is triangle SPR. As usual, we have the hypotenuse, that is 20 centimeters, and this time we are looking for the opposite side. So we are going to use the sine function. So we have sine 60 degrees equals SR, that is the opposite side, over the hypotenuse, which is 20. So this becomes 20 sine 60 equals SR. Now sine 60 is root 3 over 2. So we have 20 times root 3 over 2. That is equal to SR. So that's SR is equal to 2 goes into itself once into 20 10 times. So we have 10 root 3, which is equal to 17.32 centimeters in 2 decimal places. So we have the length of the side SR to be 17.32 centimeters. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.